In this video, we have a question. It says 2 grams of calcium react with water, as we can see by the chemical equation. What do I intend to answer in this particular question? Two things. Number one, we are going to balance this chemical equation. Number two, we are going to find the moles of calcium hydroxide that have been formed. In fact, three things. The moles of calcium hydroxide and the volume of hydrogen. So, here are the things that we're going to look at. We're going to balance the equation. We're going to find the mass of calcium hydroxide. C, we are going to find the volume of hydrogen gas that has been produced. Now, follow me properly. So to check if the equation is balanced, let's start with part A. So let's say part A. Calcium is 1 here, calcium is 1 there. Hydrogen here is 2, hydrogen is 2 plus. This 2 here multiplies everything there. So it caters for OH. So this means 2 times 1, we get 2 hydrogen. Plus 2 here, we have 4. That means we are left with 2 more hydrogens here. And the only way we can have is by putting a 2 in front. But that 2 is also going to affect oxygen, because oxygen now will become 2. Which is okay, because also oxygen become 2. So it's fine if I put a 2 in front there. And that equation is balanced. So this one, we are done. Now, next is the mass of calcium hydroxide that has been formed. So to do that, it's either we use mole ratio or we use mass to mass ratio. Whichever you feel like you're okay with. I prefer mass to mass because it's kinda easy, So let's use mass to mass ratio. Mass of calcium to mass of calcium hydroxide. So the mass of calcium given here in the equation itself is just 2 grams. But for S1, we don't know. Which other mass are we going to compare the two? Well, the other mass that we compare the two is the molar mass. Now, you might wonder, why only, well, we are going to compare not the molar mass, sorry, the relative molecular mass of all of the elements or the compound in particular play. So here calcium is an element, so we go to the periodic table. We find that the mass number for calcium is just 40 grams per mole. So just put 40 grams. That's all, 40. It's fine. But what about for calcium hydroxide? Well, this is now we can say calcium hydroxide. We find for hydrogen, oxygen, and also do the same for calcium. Oxygen here is 1, mass number 1, we get 1. Oxygen here is just 1. What's the mass number of oxygen? 16. So this gives us 16. You might wonder, why am I getting these ones here? Well, how many of each are there? Oh, there's a 2 here. So we multiply this one by 2. So there are 2, and here there are 2. Guys, there's a 2 outside. So this gives us 2, and this one gives us 32. So calcium is just 1. The mass number for calcium is 40. So it gives us 40. Then we add these. So 32 plus 2 plus 40, 74. So we put 74 there. Then we cross-check our multiplication. So this becomes 40x, giving us 2 grams multiplied by 74. So just divide by 40 both sides. Divide by 40 both sides. Eliminating 40 on the left side, we eliminate the x. So that means we have 74 being multiplied by 2, at the same time being divided by 40, which gives me 3.7 grams as the mass for calcium hydroxide. Easy peasy, right? That's all. Next is the volume of hydrogen. How do we know this? Well, we can first know the number of moles of hydrogen that has been produced. And how do you know the number of moles of hydrogen that has been produced? Well, we are going to relate the moles of calcium because it's a main element whose mass has been given or whose data has been given. So we are going to use that as our main reactant, calcium. So let's first find the number of moles of calcium. So moles of calcium, number of moles is equal to the mass given over the molar mass. The mass given for calcium is just 2 grams. The molar mass, we said it's 40. So I put 40 here. 40 grams per mole. So now we just have to divide. 2 we divide by 40. That is giving me 0.05. 05. These are moles for calcium. But why is it important to do this? Well, it's very important to do this so that we can also know the number of moles of hydrogen at play here. How? We are going to use mole ratio. So we use mole ratio now. Stage 2, we use mole ratio. So mole ratio says calcium number of moles to hydrogen number of moles. So how many moles of calcium are here? They're just 1. What about hydrogen? How many are here? There's also just what? 1. But how many moles have you calculated for calcium? I've calculated 0.05. What about for hydrogen? Well, clearly, you can clearly see that here the ratio is the same. It's 1 to 1. Are we together, right? It's 1 to 1. So automatically hydrogen also has the same number of moles because the ratio is the same. Now, if you know the number of moles of hydrogen, how do we find volume? Well, come here. Now, I didn't specify where you're finding volume at, so maybe I can just say at RTP. At RTP, to be specific. You can find volume at RTP or STP. It's up to you. So here we are going to find volume at RTP. So now, how do we find volume at RTP? Well, volume of an element or compound or any or gaseous element, well, is just equal to the moles multiplied by the volume at RTP of 1 mole of that element. All right. Now, the number of moles given here is just 0.05 moles. Then what about the molar volume in short? Let me just do this because, yeah, let me just simplify it to molar volume. The molar volume at RTP is actually 24 cubic decimeters. So we put 24 cubic decimeters. This one you need to know it by heart. If you don't want to, it's already there written on the periodic table. Just below there, you're going to find it. All right, so 0.05 multiplied by 24. And I'm getting a volume of hydrogen to be 1.2 cubic decimeters. Or you can find the volume to be, if you multiply this one by 1000, it will take you to 1200 cubic centimeters. You are still fine, my dear. So, and I hope that this video has made sense to you, most of you. If you feel like this video is really helpful, please follow me and share. I really appreciate it.